Hello everyone, this is Joe Neville and welcome to video 4 in my video series Let's Configure IPv6. So far we've been looking at IPv6 address allocation. In the last video I looked at DHCP v6 stateful, and in this video I am going to jump to the other end of the scale and we are going to look at stateless address auto configuration, or SLAAC. Here's the agenda. I'm going to show you a SLAAC demo which is focusing on a Windows 10 client and using an arubaos-switch as the default gateway. And then later on we are going to be delving into recursive DNS server and DNS search list options, which are vital to an IPv6 only SLAAC implementation. Here's the details of SLAAC then, diving straight in for all you RFC enthusiasts. It is detailed in RFC 4862. And the basic operation of SLAAC is that a client can generate its own globally routable address if it receives a router advertisement with a prefix included in it, which is a /64 and has the autonomous flag on, so the A flag is on. Here's my setup then. We are going to be focused on Windows 10 client as before, and also using the Aruba 2930 as my default gateway. And it's this gateway that's going to send the router advertisements with a prefix of 2001 DB85/64, and it's going to have the A flag on and the L flag on. So these are the defaults. I'll show you the config on the Aruba switch. You really don't have to do very much because it's also the default on Windows 10. I've got the Windows 2019 server here, but that's essentially as the destination address for traffic to show that this is a globally routable address that the Windows 10 client generates, and also because it is our DNS server. By default, a Windows 10 client, as part of the SLAAC process, will have 3 addresses. So it will generate its link local address anyway, which it uses to communicate with the local link, and through SLAAC it will generate a permanent globally routable /64 address, and it's this address which will be registered with any DNS server that the client has connectivity to. And also, so this is very different from v4 world. There are many differences between v4 and v6. This is just another one. What we have is a temporary globally routable /128 address, and this is the source address that's used for any traffic that's generated by the client. Now the reason for this, and it's detailed in RFC 4941, it's called a privacy extension. So the idea being that you have this temporary source address which you change regularly. So on Windows 10 the preferred lifetime is only 24 hours. So it's a bit like those annoying emails that you get to change your password on a regular basis. If you change your source address, it makes it harder for any ne'er-do-wells out there to track you and to attack you. Okay, and another security point is that Windows 10 by default will randomize the addresses that are generated through SLAAC. So it will not use the EUI64 process. So this process, what it did is it took the hardware address, so the MAC address, and then it adapted that to create the client address. And the problem with that is that you put something permanent, the MAC address, which doesn't change on the interface, you put that into an address. And you know, with IPv6, the whole idea is end-to-end connectivity, anyone in the world speaking to anyone in the world. Having something permanent like that on the internet or across a large network is not a good thing, because it makes tracking you that much easier because you've put permanent information into your address. So much better to randomize the address generation. So that's what Windows 10 uses by default. Okay, so the configuration points here, we've only got 2 things to configure. We have the gateway, that's arubaos-switch, and we have our client, which is Windows 10. Let's jump over to our Windows 10 client then. Here it is. So it's Windows 10 Pro 1809. So that's over on the left here. Over on the right, I have my console session to a 2930. Show version, so we're running 16.07 as before. If I show you this here we go, network settings, and we go to network and sharing center, adapter settings. I'll just show you how it's set up, because it's set up v6, there we go. So it's set up like DHCP v6, so very similar to DHCP v4, to be honest. So we're just telling it to obtain its address. Okay, so we okay that, close that down. Now I've also got set up, I'm using Visual Studio Code to run my commands as I did previously, and I need to set this up. So this is Wireshark. Start that, continue without saving, let's go. Okay, and what I've done with Wireshark here is I'm using a filter, so it's icmp-v6.type space equals space 134. So what I'm doing there is I'm filtering on the router advertisements, so the RAs. That's all I'm interested in here, so we can really drill into those. Now let's check the configuration. So nothing's going to be happening at the moment. That's because I'm suppressing the RAs on the 2930. I'll show you the config. So a show run. There we are. So globally, I'm suppressing the RAs. We've got unicast on. We're on VLAN 5 again. And as you can see, very basic configuration. All I've got is IPv6 enable there, v6 address. So we're : 254, sure, as before. And not much else. So I've left the relay on as before, but that's not going to be active here. Okay, so to fire this off then, I need to... We'll conft will take off that global, so it should start sending RAs. There we go. Also, if you haven't watched my other video, I've brought down the interval there, so that's what those two RA commands are, so that it makes it a bit easier and quicker to see what's going on. So over on our client, straight away we've got an RA. Here it is. Let's bring that across for you so you can see it. Now there's another one coming in straight away. And also I should mention, to make these stand out more, what I have done is I've gone to view coloring rules. So I've set up my own coloring rule. I just did an ad there, set up my own coloring rule to create it so that it's yellow with blue text for me, so I can pick those out a bit easier when I don't have my specific filter on. Okay, fine. So let's bring that a bit bigger for you. Okay. Now let's look at one of these then. So what we're doing is we are sending our RA. Fine. Look at our flags. Now remember the M and the O flag. We do not need those for this. It's all about the prefix for SLAAC. So this is the default setting. As you can see, all I've got is the IP address in there. Default setting. Here's the flags for the prefix. And we have the onlink flag and we have the A flag. So that's our one that's going to tell the device to use the autonomous approach to generate its own client address. So it takes this as the network ID. So that's the first 64 bits, and it will randomly generate the next 64 bits, so the interface ID, creating its globally routable address. Okay, so this is Visual Studio Code running on my Windows 10 client. I did detail my workflow in the previous video. Quick recap: what I have done is install the PowerShell extension, hit that box, type in PowerShell there, install, reload, and then create a .ps1 file like this, and it will do cool things like give you code suggestion like that, so that you don't have to remember these long verbose commands that you get from PowerShell. So you can be really lazy like me, type out the commands that you would normally use, highlight them and press F8, and then down in the terminal down here you'll get that command. Great stuff. Okay, so when you are first looking at this, I think it is wise to grab the interface index, as I have with the get net adapter command, because you might have a lot of interfaces on your client. So we're going to be looking at 17. Now normally I would run this get net IP address command with the pipe format table. But in this case, to start with, it is better to just run it, because that format table actually truncates a lot of the information. So let's run it without. And here's our 3 prefixes. This is our link local, so we're not too bothered about that. Now this one here is our permanent globally routable address. So as you can see, you've got the first 64 bits made up of that 2001 DB8A5. So that's learnt from the RA that the switch sends to it, and then the client generates the next 64 bits. We know that it is the permanent because it has a longer preferred lifetime, so that's a week that's ticking down there, and it has the prefix length of /64. And also we have the temporary address. Again, it has learnt 2001 DB8A5 and then randomly generated the next 64 bits. It's got the prefix length of 128, and you can see the preferred lifetime there is much shorter, so that's 24 hours is the preferred lifetime that's ticking down. So this is the one that we registered with DNS, and this is the one that will be used as a source address for a 24-hour period. Now let's have a look at those settings then. So it's the getnet IPv6 protocol command, where you can see, there you are. So you've got randomize identifiers is enabled there, and use temporary addresses, which is enabled. So what you can also, I've got the commands there, you can disable both of those. So if you disable the randomized identifiers, what it will do is it will still generate the 2 addresses, the permanent and the temporary, but they will be using the EUI64 method. And if you run this command here, to disable the use temporary address, you'll only generate the globally routable permanent address. So you'll only have your link local and your permanent globally routable address, which will obviously be used as your source address. That's the Windows 10 client configuration options for our address generation then. But there's a really important point I've skipped over. If you recall, I mentioned that the permanent globally routable address will be registered with a DNS server if the client has connectivity to one. But if we check with the get DNS client server address, F8 that, as you can see, V4 and V6, I don't have any DNS servers set up. So of course, if I try to ping my domain controller there using its name, I can't ping that. Okay, now if you think in the V4 world, how do you get your DNS server information? Well, you get it statically configured, or you get it from DHCP V4 in an update, so it's an option, okay? And the same with DHCP V6. It's an option there, as I showed you in the last video, or statically configured, of course. But here, because we're utilizing SLAAC and it's all auto-generated, we don't have DHCP V6 running. Now, and it's not part of the original SLAAC RFC. In the world today, 2018, a lot of implementations that are using SLAAC get around this by using the DNS server information that will come from IPv4. So it'll be a dual stack network which has DNS coming via DHCP v4, so that's already set up, and then they can still use SLAAC without having to use DHCP v6 because they can get the DNS server information from the IPv4 side. I've heard about that kind of implementation from a few enterprise networks. But what happens with an IPv6 only network? Obviously we can't do that, so we need some way of learning about our DNS server. So what's the answer? Well, of course, we're dealing with IPv6 here, so the answer is another RFC. 2 in fact, going one better. So it's RFC 6106 and 8106, which updates 6106, but they both deal with the same subject, which is recursive DNS server and DNS search list. So this is information that with DHCP v6 you would put it as an option, but because we're not running that, we have to put it into the RA. So this allows the gateway to advertise DNS server information and DNS search list information in its RA. So of course your gateway needs to support this, and I'm happy to say that arubaos-switch does support this. So let's go ahead and configure that. Here's the switch configuration then. So for recursive DNS server, what we do is we enter this command. It is IP, I know, DNS server address priority 1 and then the address of the server. And for the DNS search list information, it's IP DNS domain name, and you put the domain name in there. So through my testing, what I found with 1607 on my 2930, what we can add is you can actually put in 4 DNS servers there, and you can put in multiple domain names, but only one domain name seemed to be sent. So let's jump over to the switch. So here we are on my switch. Now I want to be able to control and show you a before and after. So what I'm going to do is I'm going to put in this command to suppress the DNS information. So we can go ND, and then as you see here, we've got this suppress RA DNS. So we'll put that in globally, so I won't be sending any. So the RAs will still be sent, but the DNS information will not. So let us configure our DNS servers for the RDNSS. So it's IP DNS server address priority 1, and it's DB8 A101, and it is 1. So that's 1. We'll put in another one as well, so you can. That doesn't exist, but you'll be able to see the multiple that can be sent. There we are. Okay, and the search list as well. Now, if you're not sure why the search list is useful, it's so that you don't have to have a fully qualified name. So you don't have to put my domain name is null06.com. So we'll enter that, and that means that I can just use the first portion of the name rather than the fully qualified name. So it just makes things quicker and lazier. I wonder if you're spotting a trend. Right, let's see that. Okay, there we are. And it puts them in quotation marks. As I said, you can put multiple in here for the domain name, but only one will be sent as per my testing. That's the configuration on the switch then. I'll show you again the DNS, still no server known. We can't ping the DC. We hop over to Wireshark and we have a look at the RAs that are coming in. Here's the prefix information. There's no extra information in there thus far, so we can create our SLAAC generated addresses, but not contact a DNS server. I need to take off this command first. There we go. Let's do that. And so then I have to wait for an RA to come in. Took a few seconds for the RAs to come in. So here is a new RA, and you can see that we've got additional information in here. So there we are. We've got an RA with extra IPv6 options. There's recursive DNS, so 3 DNS servers that we configured, and there's our DNS search list above our prefix information. So this is our extra information that we can use. And there you go. You can see the servers and you can see the domain name null06.com. So if we go back, let's have a look at our DNS servers, and there we are, as you can see. So this is the valid one, and we've got 2 other dummy ones that I entered. If you want to have a look at the search list information, it's this command here, the global settings F8, that, so you can see null06.com there. And let's try this then. Can we ping? Of course we can. So there we are. It's able to, there you can see actually, I've tried to ping win19-dc-1, and what it's done is it's created the fully qualified name there with the null06.com, and the DNS server has translated that into the actual address, so it's pinging itself finally, what we'll do is we'll go and have a look over here. And let me refresh that. And you can see the address there. So you can see that's my Windows 10 client that I've been on. So if I'm correct, 3AB7 will be the /64. So let's test that out. Let's do the longer one. So format table. So what is it? 3AB7. Yeah, it's this one here, the /64. So that's the permanent globally routable address which we've registered with the DNS server. Now we know about a DNS server, we have registered. And what was the other point that I made? That if we have the temporary address, that's the one that will be used as a source. So I'll run that ping again. Actually, I'll get rid of the filter. Let's just take that off. Let's take that off there. Run that filter. And let's go for our ping again. So we'll start pinging. There we go. And we'll go back over here, scroll down. So echo request is what I'm looking for. There's my echo request. Now, what is the source address? The source address is BF23 at the end there. So it's not there that I'm looking, is it? It is BF23. There we are. Okay, so that is showing you that our temporary address is the address that you'll see as the source address for your client generated traffic. To summarize then, we had a look at SLAAC, which allows an IPv6 client to generate its own globally routable address as long as it receives a /64 prefix with the A flag on in an array from its local gateway. By default, a Windows 10 client will have 3 addresses, have its link local, it will have its permanent global and a temporary global. Now, what do we do about DNS information? Because we're not using DHCP here. Unless you're statically configuring it, which obviously doesn't scale, then we need some extra information. And that comes from another RFC, which is an extension to the RA on top of the original SLAAC process. And that is the recursive DNS server information and the DNS search list, which are put in to the RA as part of RFC 6106 or 8106. Okay, great. So thanks very much for watching. I hope you enjoyed that RFC enthusiasts. I'll be back with the one in between. So it's a bit like the Goldilocks one. We've done one end of the scale, which is stateful DHCP v6. Now we've done the totally autonomous one. We've done SLAAC. Now we're going to go for the one that's a bit of both, where the address is generated via SLAAC and the other information, the DNS information, comes from DHCP. So that's stateless DHCP v6. So I will put that video together as soon as I can. Thank you very much for watching. My name is Joe Neville, and goodbye.